In this presentation, we're going to look at the probability of independent events. This is part of the statistics and probability series. If we have two independent events, A and B, the probability of A and B, given as here, is the probability of A times the probability of B. If we have more than two events, for example A, B and C, the probability of A and B and C is simply the probability of A times the probability of B times the probability of C. And it works like that for a larger number of events. Just multiply the component events by each other. So let's look at an example. An IT consultant is responsible for 3 software engineering projects, X, Y, and Z. Each of these 3 projects are separate from each other, so we can assume that these events are independent. The consultant knows that the probability of project X completing that on time is 0.99, so we're going to write that as follows: probability of X equals 0.99. For project Y, it is 0.95. And for project Z, it is 0.80. Okay. So the question is, calculate the probability of completing all 3 projects on time. So we complete X on time, we complete Y on time, and we complete Z on time. So we write it as follows: probability of X and Y and Z equals probability of X times the probability of Y times the probability of Z, and that is equal to 0.99 times 0.95 times 0.80. Now for a bit of calculator work, the answer is 0.7524. Okay, so let's look at another question. Calculate the probability that only X and Y will be completed on time. Well, it's natural to consider this problem as follows: probability of X and Y. Probability of X times the probability of Y. 0.99 times 0.95. But let's just be clear, this approach is completely wrong. There is actually another event that is not being considered as part of this. Notice the fact we've said only projects X and Y. This means that Z has not been completed on time. What we should have done is as follows. Probability of X and Y and the complement of Z. X is finished on time, Y is finished on time, Z is not finished on time. This is the correct approach, and it's not actually directly given in the question, so it's a sort of trick question in a way. So anyway, the answer is 0.99 times 0.95 times 0.20, and again using our calculator, the answer is 0.1881. That's the answer there. So that completes our presentation.